Let's solve power grid maintenance. It's a very good problem. Let's understand the problem statement. You will be given C power stations, where each station is uniquely identified by ID starting from 1 to C. And all the power stations are bidirectionally connected, can be represented by two-dimensional array connections. Initially, all the stations are online. The ask is you will be given two-dimensional array queries. So where if the query type is 1, then the station X needs maintenance check. So if the station X is online, it resolves the check by itself. If the station X is offline, the check is resolved by the operational station with the smallest ID in the same power grid as X. If no operational station exists in that grid, then return -1. If the query status type is 2, it means station X goes offline. Return an array of integers representing the result of each query of type 1, x in the order they appear. So let's see what the ask is. If you closely see here, you have total C equal 5. It means you have total 5 power stations. So that I am having 5 power stations. 1, 2, 3, 4 and 5. By default, all the power stations are online. So that's what's saying. So if you closely see, all the stations are online initially. And all the power stations can be bidirectionally connected, can be represented through two-dimensional array connections. Let's see here, 1, 2. So station 1, 2 is connected, 2, 3. So station 2, 3 is connected. If you closely see, directly or indirectly, the 3 is connected to station 1 and 2. Similarly, station 4, 5. So 4, 5 also connected. Now let's solve the query. So you will be given 2D query array. So where first parameter representing status, second parameter is representing station number. One represents station 1 requires maintenance check. If station 1 is online, it resolves by itself. So by default, station 1 is online so that it resolves by itself. Now what I'm doing is, now status check of the query is 2 for station 2. It means station when the value is 2, the station 2 goes offline. So obviously the station 2 is going offline now. Now let's move on further. I'm trying to status check is 1 for station 2. It means station 2 requires a maintenance check. So if you closely observe here, if the station X is online, it resolves by itself. If the station X is offline, the check is resolved by the nearest operational station of a same power grid based on the ID. Right? So if you closely see 1, 2, so station 2, right? Station 2 is offline. So that the maintenance check can be resolved by nearest station ID connected to this two. So this two for station 2, 1 and 3 are connected, but the nearest ID is 1. So that obviously here the expected result is 1. Okay, fine. Let's move further. 1, 3. If you closely see 1, 3, so station 3 is already online so that it can resolve by itself. Now what I do, I'll just say 2, 1. It means station 2, 1 means what does it mean? So station 1 goes offline. Okay, station 1 going offline. Now 2, 3. So if you closely see station 3, so it means station 3 goes offline. So number 2 representing offline. Now if I say 1, 3, so what does it mean? You need to return if the station is active, so you can return that value, otherwise nearest connected station. So if you closely see 1, 3, so 3 is already offline and the connected components of 3 or 1, 2, these are also went to offline so that you can return -1. So that's what saying. If if no operational station exists in that grid, return -1. And finally 4 comma 5. So if you closely see 4 comma 5, in this case you can return sorry, not 4 comma 5, so 1 comma 5. So 1 comma 5 means what? So station 5 needs maintenance check. So station 5 is already online, so that you can directly return that value. So if you closely see, in this case the expected output is, so this is what they are saying, right? So we need to return all the results of query type 1 comma x in the order they appear. So in this case the expected output is 1 1 3 and -1 and -1 and 5. So this is what the expected output. Let's see how do you solve it. First thing is, this is the same input we were discussed earlier. So you will be given station number, and you also given a connections array which is making a connection between the stations, and we need to figure out the queries, right? So what are the challenges you see here? First of all, we must know what are the grids are connected. What are the grids are connected? So how do you know that? It's purely a graph problem. So grid means here grid is simply nothing but it's a station number, right? So we need to know what are the grids are connected, or what are the stations are connected. So you can find out through DFS or BFS or UnionFind. So I feel UnionFind is the best way to find out whether two components are connected or not. Okay, so we'll go with UnionFind. That's fine. Now, what is the other challenge? What is the other challenge? If the station goes offline, for example, if the station goes offline, so this is the use case. Assume you have 1, 2, and 3. Assume station goes offline. So station 2 goes offline. If I say 1 comma 2, then what should I do? As station 2 goes offline, I need to find out nearest station based on the ID, right? So for 2, 1 and 3 are connected, so I need to return nearest station ID which is connected to 2. So I need to return 1. So it means one thing is for sure, we need to maintain whether the stations are connected or not. For that we can use UnionFind. Okay, it is fine. And what is the other case? When the current station goes offline, we need to find out nearest connected station based on the ID, right? How do you find out? So you will be having IDs. Each station is uniquely identified by the ID. Na? So how do you find out the smallest ID value? So obviously we should go with a MinHeap. So this problem requires the combination of UnionFind and MinHeap. Let's see how can we solve it. So first of all, you know how UnionFind works, right? So if you don't have idea on UnionFind, please check my video. I already made a video on UnionFind. So I'm going to take a route array, so which is going to track the route of each station. The station number starting from 1 ending with C, right? It means ending with N. So by default, you have 5 stations. So I'm going to take route array. So the array number is starting from 0. The index starting from 0, so that I can ignore the first index because the station number starting from 1. So you see the index is representing the station number, and the value is representing the route of that particular station. By default, when you start initially every station is independent, so that the route of each station is itself, so it becomes the route of 5, it becomes 5 only. So when the nodes or when the stations are independent. Now let's do here, you are trying to make a connection between 1 comma 2. So you can make one of the values. So if you say this is x and this is y, for station 1 the value is 1, so you can replace with station 2 value. So it means station 2 value also becomes 1. So if you closely see, station 1 and station 2 both are connected because they are having same root value. Now 2 comma 3. So station 2 having value 1, so replace with station 3, so that station 3 value also becomes 1. So it means station 1 and 1, 2, 3, 3 are connected. So they are having same root value. Now if you closely see, now you have 4 comma 5, so that you can replace station 4 value with station 5, so that station 4 and 5 are connected because they are maintaining same root value 4 comma 5. So that's how we generate a route array with UnionFind. Now, before getting into the queries, there are two cases. The first one is all the stations by default. If you closely see in this problem statement, initially all the stations are online, right? So that what I will do, I am going to make a boolean array which is representing all the stations are active or online by default. So that just take one boolean array, assume online array, station online array, so which is just an array which is representing the station number. So 1, 2, 3, 4, 5. You can ignore the 0 and all the values by default are true. Okay, so these are the values of each station. So initially all the stations are online. Now, what is the second point? I already discussed. You have 1, you have 2, and you have 3 here. When station 2 goes offline, if you want to find out nearest station ID for this 2, what are the connected components you need to figure out? What is the nearest ID value? So that is 1, right? So we need to return 1. How do you maintain that, right? So how do you maintain that? Simple. If you closely see, if you closely see, this is our, if you closely see, this is our root array, right? So you can clearly identify that. You can clearly identify that you are forming two grids, right? So 1, 2, 3 are into one grid, 4 and 5, station 4 and 5 forms another grid. How do you know that? Based on its root value. Based on its root value. Simple. So what I'll do, first I'll go with the station 1. Okay, so okay, I'll take map. So map key is the root and value is the nearest connected component, right? So I'm going to take it as a priority queue or MinHeap, priority queue of the station number. So obviously both are integers. So I'm just writing in convenient way. So let's do how do you do it. First you will have station 1. So what is the root of station 1? If you closely see, station 1 root is 1. So that you have 1 is connected to station 1. So there is no difference here. So if you see station 2, right, what is the root of station 2? 1. So it means this is the root for station 1. For root 1, another connected station is 2. Now let's move on station 3. So station 3 root also 1. So it means station 3 also connected to root 1. It means simply I'm just representing this root array in the form of a map so that I can easily find out a minimum value based on my need. Similarly for 4 comma 5. So obviously if you move on to similarly for station 4, the root itself 4. Similarly for station 5 also the root itself is 5. So that sorry, for station 5 the root is 4. So for root 4, 4 and 5 are connected. So I'm just taking one map. Now let's solve this. Let's solve this. How do you solve it? So first one is 1 comma 1. What does it mean? 1 is representing maintenance check, right? So let's move on to station 1. Okay, station 1 is already online. So when it is online, you can return the same value. So it means you can return 1. Now, if you closely see, we are trying to make station 2 into offline. So that station 2 goes offline. It means you can move on to the online array and station 2 value becomes false. So there is no expected result here. Now again you see 1 comma 2. It means now you see here station 1 comma 2. We need to see the maintenance check of station 2. Now you see station 2 is offline, so that find out what is the root of station 2. The root of station 2 is 1, right? The root of station 2 is 1. Now move on to this map. Okay, so with 1, what are the components you can which are connected? So the components which are connected are 1 comma 2 comma 3. Pick the first value. As it is a heap, right? Obviously it returns the minimum value. So first it reads the first value, which is 1. 1 is already online, so that you can take that 1. That's it. If it is offline, you can remove from the heap. That's it. So we'll move on. Now let's move on. Now if you see station 1 is going to offline. So, okay, let me make station 1 offline so that this is going to offline. Now station 1 went to offline, station 2 also went to offline. So this is interesting now. Now you have station 2 comma 3. So let me take one more input here. So for better clarity, again I am I'm just taking 1 comma 2. So let's say you want to find out 1 comma 2. So if you see, station 2 needs a maintenance check, right? So how do you figure that out? So let's move on. First, station 2, which is offline. Okay, so what is the root of station 2? 1. Okay, let's move on to root 1. So what are the components it's connected? 1, 2, 3. First you will get 1 because it is a heap, right? First you will pull 1. Now let's move on. 1 is already offline, right? So that you should not consider 1. So that what you do when you are fetching the minimum value from the heap. So first you see that first you get 1. You check online status of 1, which is off, which is false, right? So first you delete it from the heap. Now again next value, which is 2. Again 2, check the online status of 2, so which is also offline, so that you should not consider this, so ignore this 2. Now gets on to 3. Now when you next one you will get 3, right? So 3 is online, so that obviously you will take that value. So for 1 comma 2 you will get value as 3. Now again if you see here 2 comma 3, it means station 3 goes offline. So for station 3 you blindly make it false. Now again if you see 1 comma 3, so let's go on to 1 comma 3 means 3 needs a maintenance check. Go on to uh, find the root of 3. So the root of 3 is 1. Okay, what are the components connected to this root 1? So you will have only 3. Okay, you pop the 3. So you get the 3 from it because earlier we already removed 1 comma 2. You get the 3, move on to the online array. So 3 is already went to offline, so that don't consider it. So that delete it from the heap. And there are no elements in the heap, so that obviously when there are no elements in the heap, you can simply return -1. And finally you have 1 comma 5, right? So it means we need to find out maintenance check of station 5. So station 5 is already online, so that it can be resolved by itself. Now if you closely see, this is what the expected output, 1 and 1, and here we got 3 and -1 and 1, -1 and finally 5, right? So that's it. So this is the expected output we need to return. So hope you understand the dry run. So what I'm trying to say, first you generate a, first simply you generate a union find with the root array. Then you can also maintain online status of each station based on a boolean array. Then we are representing the grid. So this grid, right, this grid is simply represented by map. If you closely see, so these three components are connected with root value 1, so that with root 1 we will connect all those components. With root 4 we connect 4 comma 5. So whenever you are trying to find out a maintenance check, for example, if I want to find out a maintenance check of 1 comma 3, so first I will take the root value of that station 3, find out the connected components, take the minimum as it is heap, each time it will return the minimum value. When it is returning minimum value, check that minimum value is true or not. If it is true, that is the answer. If that is not the true, you delete it from the heap and go on to the next value until your heap becomes non-empty. So that's it. So if you closely see the time complexity, right? So let's talk about the time complexity before writing the code. So what are we doing here? What are we doing here? So first one is we are constructing union find. Okay, so we are constructing a union find. Uh, so obviously the union find has two operations. One is find, another one is union. Here you have x and here you have x comma y. So obviously the find method on an average it will take constant time because we are going to go with path compression. So you will know, I think you already know it, while writing the logic you will get to know it. Even the union also operation takes constant operation. So for making components connected, so to generate this array obviously it is going to be constant. Okay, fine. Now let's move on. What is the second operation we are doing? We are also taking online status of a boolean array. So which is obviously this is the boolean array. To find out a status of each value is always going to take constant time. And what is the third operation? We are taking a map of root comma connected components in the form of heap, right? So the root may contain all, for example, all the components are connected. So in this case, the root one, it have all the values present in the grid. So, and if you keep on, if you keep on, if all the values gets into offline, it means you are trying to pop every value from the heap. So obviously, when you try to pop the value from the heap, generally, if you take a single value is deleted from the heap, it will take log n. But when all the stations are went offline, right? It means you delete all the values, so that it is for each value it is going to take log n. When there are n values, it is going to be n log n. So if you closely see the time complexity for union find, if you for the construction of union find, almost it is constant time, and for construction of online status, which is constant time. But to find out the nearest uh, station within a grid, obviously in worst case it will take n log n. So the time complexity is n log n. And what is the space complexity here? So if you closely see here, what are we doing? For union find, we are going to take n stations, plus for online station also we are going to take n stations. And even in worst case also, even this map, right? This map also in worst case, which is going to take n, so that obviously which is going to be big O of n. That's it. So obviously you can say this is 2n, but you can make it as n. That's it. Hope you understand the concept behind this. Let's go and write the logic. So let me write the code. So what I'm trying to do, I'm going to generate, a, I'm going to use class union find. So union find, and which in turn takes the root array. Okay, so this is my root array. So initially, this is my union find, which initially take the size, and I'll just take the root size as new integer of size plus 1, because the station number starting from 1. So initially each station is independent. So I can just take, you can take station which is starting from 1, and station less than or equal to size, station plus plus. So each station is independent. So the value of each station remains the same. So the value of each station is equal to its station. That's it. So we generated a union find object. Then we are trying to find a root of each station. So let's say the station represented by x. And when do you say that it is a root, right? So when the current value, when the station number and its value is equal, then you can say that it is a root. If it is not equal, then obviously what do? You will do the path compression. So you will find the root of its value. So it means finding the root of its value, and that root you will be assigning to here. So this is a concept of path compression. So this is a great improvement. Hope you get it. If you don't understand this, please watch my video on union find. Finally, you can return root x. That's it. This is find. And if you want to write a union method, so public void union, and you will take x and you will take y, and you will just take root x, which is find of x, and root y, which is find of y. Okay, fine. Now simply what do you see? Root of root y equal to, you make it as root x. That's it. So hope you get it. Done. So we were able to write a union find. I didn't use ranking, but this is fine. Now let's move on. And what is our choice? We generated a union find. So then what is our choice first? First, we will create a union find. Okay, so union find, you can say is UF, new union find of the given size, which is C. Okay. Now I'll also take a Boolean array. Which is representing the online status. You can say online status of each station. so which is a no boolean array of given t. And by default, all the stations are online, so that I'll just fill all the station values with true. Okay, fine. Now let's move on. Now let's make a connections between the stations. So just take per integer, you will get a connection from connections. Okay, then what is your job now? You just need to make a connection between them. So union find of union with let's take it as a connection. Uh, 0th position you have source and destination. First index you have destination. I'll just did it. Done. So what is the next choice? If you closely see here, what we did here, once we form a union, right? If you closely see, once we form a union, the root array and with union operation, then what we did, so we are trying to find out the map array so that I can find out when the particular station went offline, I can find out the nearest ID so that is going to be the new result. So let me do that so that I'll map with the root the associated values. So in this case you have root 1, right? So for root 1 you have values 1, 2, 3. For root 4 you have values 4, comma 5. So let's do that. How do you make it? So simple. So I'm going to take a map here. So map which is of integer. So the value key is the root and value is going to be the priority queue. So because I need to find out the minimum value so that I just make a min heap. So this is my grid. I can say it is my grid. So you can have new hash map. Perfect. So let's do that. So you have for value 1 and less than or equal to c n plus plus. So we want to find out root of each station. So you can take it as a station and starting from 1 and station less than or equal to c and station plus plus. We need to find out root of each station. So this is my root. So how do you find out? So on the union find, you can call the find method by passing the station number. You will get the root. And for this root, we will add the current station. Okay, so for this route we'll add current station. So first you check uh, put if absent. Okay, absent, if the root is not present, it will just create a min heap with priority queue. Perfect. So what we do, we'll just try grid dot get off. For this route we will just add the current station. So that is what we did earlier. Perfect. So we are done with route grid mapping. And for this route, what are the components are connected? So we'll just added them. Now it's time for us to solve all the queries. So these are the queries, right? So let's do that. So what I'll do, I'll take a list of integers. So I can take it as answer or a result, you can say, and new array list. Now let's move on. For each query, right? So you will have integer array and you have query. From the queries, let's say you have status, you can which is presented in query of 0, and you also have station which is presented in query of 1. Okay, now let's say if status which is equal to, it means we need to mark station into offline, right? So mark station as offline. Okay, so simple. So let me do that. If station equal to, so whatever station you have, we need to mark it as offline so that on online status of this station is going to be false. Okay, so which is going to be false. Fine. Let's say if station is equal to 1. It means, what does it mean? So if it is not 2, obviously it is 1. So you can say, uh, you don't need to do that. So if it is not equal to 2 means it is obviously 1. So what you need to see, uh, obviously if the current station is online. Okay, so let's check that if the current station of this station, online status is equal to true. You don't need to write it specifically, but for your clarity sake I'm just writing. So for this station, online status is true, and this is going to be the result, right? So obviously you can add this into result dot add of station. That's it. So it means, status is one, and the station online status is true, right? So obviously you can go, you will add that to the result. So then else, what does it mean? It means the online station status of this station is not true. Then you will come here. Then what do you need to find out? We need to find out the grid, right? So to find out the grid, find out what is the root of it. So that's what we are doing now. So that's what we are doing. If you closely see the diagram here, so that's what we did. If you closely see, let me explain that. So what are we trying to do? We will find out a root of that grid and find out the nearest connected component. So that's what we are trying to deal with it. So let's do that. Okay. So first find out a root of this station. So union find of station root. So it will return the root of this station. Now this is where the tricky part comes up. So you are going to get a priority queue. Okay. So priority queue of integer. So it is a, let's say, connected grid. You can call it as a connected grid. So from the grid you can call or connected components, whatever it is, or I can simply take it as a min heap. So this is our min heap. So grid dot get or default. So just to avoid the null pointer, I'm just doing get or default. For this root, if it is present, it will return. Otherwise, return a empty priority queue. Okay, that's fine. Now this is where you will get a connected components in the form of min heap. Now let's see. Uh, so if this heap is not empty, okay. So if this heap is not empty, and whatever top value present in this heap, right? So generally you will get heap dot peak. It will return the minimum value. If this value status is offline, okay. So if this value status is offline, then I should not consider it. So obviously I can delete it from the heap. That's it. Now finally you will find by the end of this for while loop, so you will find out a heap, either it contains the empty status or it contains the valid value. So what do you do here? Now you can find out the valid nearest station. So you can say nearest station. The nearest station could be, if heap is empty. If heap is empty, it means you couldn't find any station near to it, so that you can return -1. Otherwise, you can return heap.peak. That's it. You will add this nearest station to the result. So result dot add of nearest station. I know this is pretty lengthier problem. Hope you following me. And finally, what we do, we need to take this result and return it. So if you closely see, they are expecting in the form of integer array. So I'll just write, you can write a for loop, but for simplicity's sake, I'm just writing a streaming API in Java. So you have a map to int. I'll take each and every value, uh, int value dot to array. Array, you can do one thing. You can write a for loop and just return it. That is also, this is also does the same thing. Let's see, does it return any compile time errors? Array index out of bounds. Let me go there. There is a slight. Where is it? Yeah, so online status, right? So generally it is starting from 0 to 1 to n, right? So you can make it as c plus 1. Even union find also you can make it as c plus 1, so that you can avoid size plus 1 here, so that it will be uniform. So let me run. Okay, I get it. As you avoided there in the union find, you made less than or equal to, just avoid it. So that's it. So let me submit. That's it. Hope you like the explanation. Please subscribe and share. Thanks for your time. See you next time.